Hi guys, and welcome back. This is actually the last notes that you will be taking from me, so congratulations. Um, we are going to be doing a test for the next e-learning assignment after this one, and the test will be on genetics. So can you do normal dominance? Can you do codominance, incomplete dominance? And what I'm about to teach you right now, which is blood types. Um, so with that, take some notes either on a sheet of paper or on this one. The way it's going to work is I'm going to have you take some notes on this page, and then we'll do a little bit of practice, and then this part will be your homework. All right? So go ahead, write this down either on your sheet or on a loose leaf sheet of paper. So antibodies, what are they? They are a large Y-shaped protein that is used by the immune system to identify and neutralize pathogens such as bacteria and viruses. All right. So I always thought blood type stuff was neat because everyone here has a blood type. You do, I do. And your blood type determines who you can give blood to and who can give blood to you. And there's even some neat facts down here. So like for blood, every one person in 100 is type AB negative. Every one person in 50 is B negative. One person in 33 is AB positive. Every 1 in 3 people are O positive. So it kind of gives you a breakdown of how frequently you come into something. And based on these antibodies and antigens, it gives you an idea of who you can give blood to, who you can receive blood from. Will you have a hard time getting blood if you need it? Are you someone who's really high in demand when they do those blood drives because you can give blood to everybody? Those are all kind of interesting things that tie in with this. So that is antibodies. All right. That should be a lowercase s there. All right. Antigens. All right. And this will all make more sense in a minute once I start drawing things. Antigens is a protein that serves as a target for the receptors of an antibody. Just make this box a little bit bigger. Okay. Period. All right, so there is the start of your notes. All right, now in order to do the rest, I'm gonna have to go into Paint. So let me do that right now. So here is our stuff in Paint, and I'm gonna have to draw some pictures. So if you have blood type A, let's do this. Let's draw a circle. This is representing your blood cells, these things here. And in the middle of that, let's put a big letter A, so then that way we know which one we're working with. Okay. And then the antigens that are a protein that serves as a target for the receptors of an antibody are going to be the A antigens. Let's make that a little bit smaller. Okay. And the A antigens are going to look like this. It's going to be a little line. And then at the end of that line is going to be a circle. All right. And we're just going to keep doing that over and over again. And each one of these is an antigen. All right. So think of antigens as little flags that identify to the rest of your body that says like, hey, this is part of your body, that it is what you're expecting. All right, so I had a little bit of a change of heart. What I'm going to do is I'm going to draw what each one of these looks like first, and I'll have you draw along with me. And then I'll go down here and I'll explain what's going on. I think that'll make it a little bit easier to see. So this is what A is going to look like. It's going to be a circle representing your blood with all these little prongs with circles on the end coming off. All right, and we'll talk about what that means in a minute. Let's do blood type B. All right, so in actuality, it's the same size as blood type A. I'm just making it smaller because I kind of ran out of room. All right, so let's put a capital letter B in there. Okay, and for blood type B, it's going to be like blood type A, except instead of it being circles on the end of the sticks, it's going to be diamonds. Okay, so go ahead and just like I'm doing on your notes, draw out this bunch of sticks with diamonds coming off of blood type B. All right, so there's blood type B. It's a red blood cell with a bunch of sticks with diamonds coming off the end. All right, now let's do blood type AB. Capital letter A and B because it's blood type AB. All right, and what do you think is going to be coming off of blood type AB? You guessed it, it's going to be a little bit of blood type A and a little bit of blood type B. So you're going to do a stick in a circle, like that. And then the next one is going to be the stick in a diamond. And then the one after that is going to be a stick in a circle, followed up by stick in a diamond. All right, and you're just going to kind of carry on with this process. You're showing parts of A and parts of B. The circles are for A, the diamonds are for B. That's why it's blood type AB, and they're just going to kind of alternate. So let's go ahead and fill the rest of that out. All right, last one up is blood type O. All right, so let's make our red blood cell. Let's draw O in there. And O is going to be kind of interesting. Blood types are kind of interesting because they're kind of a mix of what we talked about before. There is regular dominance and recessive alleles. And then there's codominance, what you're seeing here with the AB, where you're showing kind of parts of both in a splotchy sort of pattern. O is recessive to all these types. So it's recessive to A and it's recessive to B. So in order to have blood type O, you have to have two O alleles. Whereas if you have blood type A, it could be big A or big A O. All right. So here's what blood type O is going to look like. You're going to have just a bunch of sticks. They're not going to have any diamonds or circles coming off because it is recessive. All right. It is not expressing any of those parts. Okay. So here's where it might make a little bit more sense, all this stuff that I've been doing. So antigens are going to be the A antigens. Antibodies are going to be anti-B antibodies. So let me go and write that in there. Anti-B antibodies. All right, and what that's going to look like is it's going to be looking like, like this. All right, so you see how these antibodies are going to go, and they're a Y-shaped protein that's used by the immune system to identify and neutralize pathogens such as bacteria and viruses. These antibodies, these anti-B antibodies, see how they would fit really well onto one of these? Like if I was to draw one and it would bond in right here, and it would be like a flag for your immune system, which would say, hey, this isn't supposed to be here. People who have type A blood have these anti-B antibodies because they're only supposed to have blood that has the circles on the end. If they have blood with the diamonds on the end, it's going to fit neatly into that slot because they're producing these antibodies and they say, hey, wait, this blood isn't supposed to be here. Get this out of here. And usually that's used for bacteria and viruses because they have these sort of receptors, and it's how they fool your cells. They'll have these A antigens and the B antigens on them. So if your blood has any sort of thing that's foreign in it that has these diamonds on the end, it's going to have these anti-B antibodies to get rid of it if you have type A blood. All right. So the possible genotypes for something like that, if you have type A blood, are going to be two options. It is either going to be big A, like I said, A and B are dominant, or it's going to be big A O, because O is recessive, so that's another option. Okay. All right, let me delete this drawing here and reset us back to normal. All right, next part. Antigens. It's going to have B antigens. All right. So just in case you haven't figured it out, A antigens are the circles on the sticks. B antigens are the sticks with the diamonds. Antibodies, it's going to produce, just like over here, it's going to produce antibodies. But this time, it's going to be anti-A antibodies because it only wants B-type antibodies in there because it knows that if anything doesn't have a B-type antibody, it's foreign and it's not supposed to be there. All right, so these anti-A antibodies are going to look like this. All right, so these anti-A antibodies are going to look like this. And again, notice how this sort of structure is going to fit in neatly over here, like this. All right, so these anti-A antibodies would bond to something like this because it kind of encloses this circle here. All right, whereas it wouldn't work very well with this because it wouldn't enclose it quite so well. All right, so the genotypes for something like this, if you have type B blood, is going to be kind of similar to type A. It's going to be either big B, or it's going to be the recessive version. Or sorry, not the recessive version, but the version that has the recessive allele, like that. So it can either have two dominant types, so it'll be type B, or it could have one and still be type B because O is recessive. All right. Next one, we have type AB blood. Again, let me clean up this picture a little bit. You know what? Never mind. I'm going to leave it there. All right. Antigens for type AB blood. All right. It's going to be A and B antigens because it has both the circles and the diamonds. These are the antigens. So here's the A antigen, here's the B antigen. All right. The antibodies is going to be none. And the reason why it's going to be none is that, remember, these things kind of flag down the white blood cells. So if you are type B blood and you're producing these anti-A antibodies and it bonds to something like this with the circle, what it's doing is it's saying to that white blood cell, hey, destroy this, because this isn't supposed to be here. We're only supposed to have B antigens here. All right. So if type AB blood had anti-B or anti-A antigens, it would start bonding to its own blood cells and destroy its own blood. So that's no good. So you have to have no antibodies. All right. The possible genotypes for this are pretty simple. It's going to be AB. That's the only possible genotype. It's the codominant one. It's the one that has both. All right. For over here, antigens. For type O blood, it's going to be none. The reason why it has none is if you look, there's no circles, there's no diamonds. It has no antigens. All right. For antibodies, it's going to be both types that we talked about. It's going to have both anti-A antibodies and anti-B antibodies. All right. And the reason why it's doing that is if it has anything in its blood with these diamonds or these circles, that isn't supposed to be there because for type O blood, they don't have any of those any of those antigens. All right, so it knows that it's foreign the moment it sees anything like this. Possible genotypes, there's only going to be one. It's going to be OO because O is recessive for blood types. That is the only way you could possibly have something with type O is if you have both recessive alleles. All right. Okay. Now, back to some more notes. All right. So like I said before, the following blood types are dominant. A is dominant and B is dominant. All right. The following blood types are, actually, let's do this. Let's say type A and type B. So there's just no confusion. The following blood types are recessive. Type O is recessive, and codominant is going to be if you have type AB blood. Okay. Rh factor is a special little thing that we haven't talked about yet. So let's talk about that right now. All right, so Rh factor is a set of antigens found on the surface of red blood cells. All right. So really what Rh factor is you guys might have heard of blood types before. It's not just like, oh, I'm type B blood or I'm type AB blood. There's AB positive, AB negative. So these Rh factors are saying like, oh, you're positive or you're negative. All right. Here's what that looks like in terms of a picture. If you are Rh positive, then you are going to have you have the Rh antigens, and you are dominant over negative type. All right. What that'll look like in terms of the picture is you'll have, in addition to the what we had before with the circles and the diamonds, you'll have another pair of antigens which will look a little bit different. So like, let's say that you have a bunch of sticks with little stars at the end, in addition to what you would have had before. So in addition to having diamonds or circles as well. All right, so you'd wind up having something that looks like that. All right, if you are Rh negative, then you do not have the Rh antigens, and you are recessive. All right, so positive is dominant over recessive. All right, and to show you what that would look like, you would have a blood cell. Let's call it negative. All right, and it would look kind of like, it would just be a bunch of sticks with nothing on the end. So it's showing that you don't have those antigens that would be there with the positive type. Okay. All right. Let us try a little bit of practice. All right. So it says Jane has type AB blood. John has type O blood. What possible genotypes, meaning the letters, and phenotypes, meaning how it looks, can their kids have? What are their percentages of these phenotypes and genotypes occurring? So this is kind of why I like blood typing, because it gives you actual real world stuff. Like if this person has AB blood and their partner has type O blood, what are the odds that they're going to have kids with a type A blood? What's the odds that they'll have type O blood? So that's kind of neat and kind of practical to your life. If you know that you're going to have a baby with someone, you can actually predict what type of blood your child might have. All right. So let's take a look at this problem and try it out. All right. So we got our Punnett square that we drew. And now we also know that Jane has type AB blood. So we also know from our notes that for type AB blood, that the only possible genotype for someone with type AB blood is AB. So we're going to do the Punnett square the way that we have done it in the past. We are going to separate out those alleles. There's going to be an A there, and then there's going to be a B over there, like that. Okay? Going back to the problem, it says John has type O blood. So let's take a look. For type O blood, you are only going to have this possible genotype, OO, like that. All right, so let's write that in over here. Type O blood, type O blood. Okay, and let's fill this in as well. We got AO, we got BO, we got AO, and we got BO. Okay, back to the problem. What possible genotypes and phenotypes can their kids have? All right, and what are those percentages of them occurring? So the genotypes that they can have are AO, which is going to be there 50% of the time, 2 out of the 4, and also BO, which is also going to be there 50% of the time. Okay. All right. So, and for phenotypes, which is how you look, you are going to have type A blood 50% of the time. Okay. Because that would be how you look. You'd look like you have type A blood. It only takes one letter, because it's normal dominance for this, to have type A blood. And then you would also have type B blood 50% of the time as well. Okay? So that would be the answers to that problem. This one right here. All right. Now, what I'd like you to do is I'm going to include this video. I'd like you to go and watch it. It's about 3 minutes long. And then we'll come back and we'll try another problem. This kind of just shows you what I've been talking about with a little bit of real motion, a little bit better motion. So go ahead and watch that. All right, welcome back. So let's try out this problem. I'd actually like you to try this one out on your own real quick to see how you do. See if you get the answer that I do. Go ahead and try this out now. I will put on some music and let's see how you do. All right, welcome back. Let's see how you did. So it says, if A is codominant with B, what offspring would be possible from a cross between two AB blood individuals? That means that these two AB blood individuals mated. That's what cross means. And include the probability that they're going to occur. So I have someone with type AB blood, so that's going to be an A and also a B. And over here, again, they were mated with someone that also has type AB blood, so it's going to be an A and a B. All right. Inside, this A is going to come down. This A is going to come across. We're going to have type AA. Over here, it's going to be A and B. Over here, it's going to be A and B. Over here, it's going to be B and B. All right, so possible genotypes. Remember, genotypes is just a letter. AA is going to be there 25% of the time because it's 1 out of the 4 boxes. AB is going to be there 50% of the time because it's 2 out of the 4 boxes. And BB is going to be there 25% of the time because it is 1 out of the 4 boxes. For the phenotypes, the percentage that you're going to have type A blood is going to be 25%. The percentage of that time, because if you have at least 1A, you're going to have type A blood. The percentage of time you're going to have type B blood is also 25% because if you have at least 1B, you're going to have type B blood. AB, though, is going to be there 50% of the time because half the boxes had type AB blood. Remember, you have to have both an A and a B to have type AB blood. And O is going to be there 0% of the time because none of these boxes have OO for them. All right. So if you got that right, your homework is to do the rest of the problems here. Good luck, and let me know if you have any questions.